Friends, welcome to Mule session. In last session, we started the batch processing and we discussed about some introduction about batch processing, right? So ideally, the batch processing is intended for processing larger than memory data sets. That's what we discussed yesterday. In order to, if you load the 1 million of records into your memory is not sufficient to process the entire records. So it's better to process in some batches, some blocks of data. So that's the primary intention of the batch processing. And while processing, the process should be reliable and concurrent and better having better error management strategy. So we are looking for these three kinds of features while processing the batch. So there are some alternate features like for each and parallel for each. Using these constructs also, we can process the records for each and parallel for each. So for these two, Parich and Palraf, if you take the example of Parich, so what happens in case of Parich? It is sequential. We process record by record. So if it is record by record sequential process takes a lot of time, so it is not ideally good option. At the same time, it doesn't provide the better error management strategy. And if at any crash happens in middle of the for each processing, we need to start process from the beginning. So for each is not right candidate. The same applies for parallel for each. Parallel for each gives the parallel processing. Yeah, that's we achieved, but at the same time, it is not reliable and it doesn't have better error management process strategy for parallel for each. So as these two options are rolled out, the batch processing is one of the best strategy to process huge amount of data. And batch process gives the reliable, batch process gives the concurrent execution, and batch process gives the better arrangement strategy. In today's session, we're going to discuss about what is the different phase in the batch processing and what happens in each phase, and how batch processing use good reliability and better arrangement strategy, and how batch process use the parallelism. So very important concept, very important this concept you need to understand to crack your interview and to understand batch processing in deeper manner. Okay, let's start. See, I have a 1 million records, a huge amount of data that's coming from a database or FTP or file system or some HTTP source or somewhere, some source. I have a huge amount of data to process. This is source system, right? And I need to migrate this entire data. I need to transform this data, migrate to the Salesforce or another database, this target systems. Okay, this is one of the use case I'm taking out to explain the batch processing. Okay, so batch process happens in three steps. The first step is the load and dispatch phase. Load and dispatch, this is very important phase, but it is implicit phase. You can't see this phase in batch processing, batch job component, right? So loads and dispatch is load and dispatch phase. Load and dispatch phase, the first. And second phase where actual processing happens is process records phase. Process records phase. And third phase is on complete phase. To remember this, just keep in mind that this is before processing the records. This is a preparatory kind of stuff. It's before. Loan dispatch happens before processing records. In process record phase, actual process happens. In on complete, after processing the records, it's kind of reporting stuff, how many failed, how many success. This is after processing. This is before, after, and actual. Remember like that. Okay. And the important point to understand is what happens in each phase. And load and dispatch phase and process record phase are very important to understand your batch process deeply. Okay. So what happens in load and dispatch phase? We take the first phase. When the load dispatch phase starts and what happens in the load dispatch phase, right? So when your mule flow, we will configure something called batch job component in the mule flow. When we give input to the batch job component, the loaded dispatch phase starts. Now let's see how the batch job component is, and what's different sections of batch job component, and what is the configuration of batch job component. We will understand now. Batch job scope is a scope that used to process the records in the batch. Mule provides this batch job scope. Okay. So this batch job scope, you can see process record phase and non-complete phase, and load dispatch phase is implicit. It's not visible over here, but some activity happens here. I will tell you. Okay. So when we give input to the batch job component, load dispatch phase starts. Okay. So what is our goal? What is our intention? We need to process huge number of records, right? And to process huge number of records, right? First, we need to prepare the processing. First step is prepare, right? What happened in the load dispatch phase? What kind of preparation we do in the load dispatch phase? Understand this first. Okay. Assume there is about 200 MB of file you need to process. Assume, right? So what I'm doing is to process 200 MB of file, and there is in your machine. This is your machine where you configure the batch job component. Okay, this machine, and what I'm doing is I'm loading this 200 MB of file into my local, my machine or server local. Okay. So where is the in where you can load this 200 MB file to your local? You can't. I don't want to load this entire 200 MB to RAM at first. So what I do is in your local server, your hard disk, in your laptop or hard disk, right? Hard disk can have enough message, enough space to load this data. So temporarily, I load this data to my hard disk because RAM is limited. RAM has some limitations. It is about 16 GB or 8 GB, or some limitations, right? But my hard disk is vast, 1 TB or 2 TB, 5 TB hard disk also. Hard disk is vast, so I can have enough space in my hard disk. So I can temporarily load this 200 MB file to my hard disk. It's temporary. Remember, it's not permanently. I'm storing this to one 200 MB memory, 200 MB, 200 MB file to my hard disk file or something. So how I am storing? I am storing this data in terms of persistent queues. In terms of persistent queues, right? So queues means I'm making this data it possible to easy to process. I'm making this data as the records in the queues. So there is record one, record two, record three. Assume that some records. Assume these are 200 MB contains 1 million records, 10 lakh records, right? And I'm loaded all the records to the like 10 lakh records to my hard disk in a persistent queue. Now the data become loaded to your local, your machine from remote to the data is available to process in your local machine now, right? It's local to your processing. Then from local to hard disk to I need to load into my RAM because your processing happens only when we load to memory to RAM. Directly we can't process from hard disk, right? So I can't load this entire 200 MB again to RAM, right? What I need to do, I need to load in terms of blocks. That's what I told when in introduction. We need to process in the blocks, right? Blocks of what? While configuring your batch job, you need to give the batch size. Ideally, it is 100. By default, is 100, right? But you can give more than 100 also. You can batch size. So whatever size you mention in the batch job configuration component, that many blocks are getting created. right? Now have 1 million records are loaded into a persistent memory. That many blocks are get created. 100 records blocks are created into your hard disk. This all happens in load dispatch phase, first phase, internally. Okay, so the blocks got created, and there is thread pool got created, thread pool to process these blocks. Okay, to process anything, we need two things. One is memory and the CPU, right? Thread pool means CPU instances. Okay, so in thread pool, there are different threads got created. How many threads are created? How many threads created depends upon your system capacity or server capacity. Assume your server is dual core, two cores are there, two CPUs are there, then four threads will be created. Your server is of quad core, then quad core means four cores, four CPU available, then eight threads will be created. Your server is octa core, then 16 threads will be created into core, two into core number of threads can be created. Assume my system is a two core system, I have four threads created, right? And then what happens is these four threads, each thread took one block of 100 records, right? Assume block size is 100. Each thread picks one block and loads that block to a RAM. This is block 1, block 2, block 3, and block 4. Each block contains 100 records, right? Each block contains 100 records. And four blocks got it loaded into a RAM. Then I have four threads. Each block, each thread takes one block, and for example, there are four threads T1, T2, T3, and T4. These four threads, each thread took one block, and T1 takes first record of the block one and execute through the step one. Same time, 3 to T2 take the first record of block 2 and execute the step 1. And T3 also take the first record, execute. And four records will be get processed inside your batch process components to the step 1. I can tell you what is step 1 and step 2, what is significance of steps little later, but try to understand this parallelism, how the parallelism getting achieved in batch processing. Because I have multiple threads, each thread processing each one block of 100 records. This thread one process record by record sequentially in this block. Okay, it takes the one record and process the step one, and take the second records, process step one, and process third records, process step one. Likewise, for each record inside this block, it executes the step one. Okay, after it finishes the all the 100 records, the block one again move back to your hard disk persistent queue, right? So likewise, these four blocks are concurrently get executed. It's not like after block one, block two, because the separate threads executing these blocks, right? These four blocks are concurrently get executed. Maybe chance that T3 executes the block three first, and block three may come to person queue first. Block four might have completed first. It is not random manner, right? So all the four thread execute the four blocks, right? After processing the four blocks, they come to your persistent store. Again, the thread picks those four blocks and execute the step two also if just step two exists. Okay. So likewise, the parallel processing happens. Now try to understand what is the step one and step two. Okay, the entire process I can't do there is in a one single step. It's better to you know process in two steps. Two steps at least. What it depends upon the requirement. What's the steps actually? See, you are processing some employee payroll, right? In employee payroll, there certain rules are there. If employee is a full time, that is a different rules you need to process. Employee is part time, there are different rules. Employee gender is female, there are some different rules. Employee is male, there are different rules. Maybe different how for each record, for each employee has different. Maybe the category of employees have different kinds of processing. You can't put entire processing in one block. You will dedicate a block for for different category, so that you can put your logic cleanly, right? So that for that you can step in one step, you categorize some employees, you process only those employees, right? Then you can allow those employees only to go inside that block. For that I can configure something like accept expression. Accept expression, the condition where it checks on the record, is the record eligible to go inside the process, the block or not, the step or not. Okay. And I can define one more step for processing a different full-time employees, or one step for processing a part-time employees. Like, and I can define a number of steps, depends upon my requirement, my business requirement. I cleanly define logic over here. That is a primary advantage of steps. And one of the advantages, another advantage for the step categorizing steps is, after processing first step, it is not guaranteed that all the records got successfully executed in the first step. Maybe some records, the records is not proper, the data inside the record is not proper, the chance of getting failures, right? Errors, chance of getting errors. Okay. So I dedicate another step to process the error records that are not successfully get executed in step one. I put some other step that I will process those error records. Okay, okay. So I can configure one step that will process only the success records, those successfully processed in the first step. So I have a regulator, a controlled mechanism of error handling, and for define some steps to process the records which are successfully executed in the first step and will not execute first step, right? So that's a fine grained error handling facility I get while doing the batch processing. And for that, I can configure something like accept policy in a batch step. Accept policy tells that what kind of records we want to enter to the that step. We want to process all the records, or you want to process only the records that successfully executed in the first step, or you want to process only the records that failed in the first step. So you can something called accept policy. We configure on stop of step, so that only those records are allowed to execute in that step. Right? And likewise the blocks will again move to there assume there are two steps. If all the steps, all the blocks got executed in the first step, they again move to the persistent queue, and again these threads picks those blocks and put those blocks back to RAM. And again the all the blocks get executed, and afterwards we get on complete phase. On complete phase is a reporting phase, how many records successfully executed, how many failed, like that. And see, we get the parallelism, parallelly four blocks executing. And we get the fine grained error handling mechanism by defining the one block, one step for handling the failure records, like that. And how can you get the reliability, like when system crash happens, because we are processing 1 million records, and so many blocks got executed, and finally when executing some blocks you got an error, system you got error, or your system got crashed. So in that case, how can I load only those blocks, those not executed so far. How can I identify, how can system identifies the blocks that already get executed, right? For that, each record in the block has two parts. One is the record part and metadata part. This metadata part tells which step successfully executes and which step is pending. For example, there are two steps out there. Okay. And this record, after executing the first step, it tells us, okay, first step got executed. So it marks something like that. Okay. First step got executed, first step got executed, right? Then what happens after first step execution completes, the system got crashed, right? And once the system got resumed, it will check the record is what stage the record is, how many steps the record executed. If it identifies that the first step completed and it is we need to execute second step, then the process won't you know um, won't execute this record into step one. It directly moves this record to step two. Okay, metadata component tells the status of the record, how many steps it got completed. Based on that, your threads move that blocks to the corresponding steps. Okay, so that I can achieve the reliability when system crashes, right? And in the on-complete phase, we get the object called batch job result. It contains the entire information of the batch, how many content, how many success, how many failure, like that. Okay. And one more control mechanism is you are executing 1 million records, and out of 1 million records, it's okay if 10 record fails out of 10 lakhs. If 10 records fails, it's okay. You want allow, right? Those 10 records you want process some a different step, and you want to process in different manner. But because of these 10 records, you don't want to stop your execution, right? You can mention like how many records is okay, how many records it's fine to fail. For that, there is configuration called max fail records. You can configure that. If you configure the number like okay, for my 10 million, if 20 records fails also, that's good. Then you can configure like that. And if you want to config continue even after any number of failures out of 10 lakhs, if at one time 1000 fail also, that's fine. 2000 fail, that's fine. Even 10 lakhs fail, that's fine. You want to, you don't want to stop your execution with errors. In that case, you need to put as a -1 as max fail records. If you put -1 as max fail records, even after failure also, your system continues to move to all the steps. Or else, if you configure something after first step, your system got stopped, execution got stopped. Okay, so that's about the max fail records, right? So this is about the activities that happen in load dispatch phase, process record phase, and on complete phase. Let me summarize today's session about these three activities. So what happens in the load dispatch phase? Load dispatch phase starts when we give input to your batch job component. First point. Second point, in the load dispatch phase, your all remote data is copied to your local hard disk in as a persistent queue, right? All 10 million records, all the million records were loaded to your persistent queue, and each record has two parts: record and metadata part. And each these data into divided into blocks depends upon the block size we configured in the batch job, right? And a thread pool will get created based on system capacity. That threads are loaded into your thread pool. So up to this point, load dispatch phase. In the process record phase, what happens is these threads picks the blocks and loads those blocks to memory, and these threads executes those blocks record, the record by record. Each thread executes the one block record by record, so that the blocks inside record will get executed concurrently, right? Like story like a beacon, this processing happens in the load and process record phase. After all the blocks and all the steps finished, then in the incomplete phase, we can get the batch job result as an object. It contains all the reporting information like how many failed, how many success, like that. Okay. So this is about the batch processing theory. In the next session, we see about the demo of the batch process. There I can show you where the data stored in your hard disk, and what is the batch aggregator, what is the importance of aggregator. So these also I can tell you while executing the demo. Thank you so much.